So Zscaler architecture we need to understand, right? So we need to understand what services we get from Zscaler, right? And how we can deploy it in our environment, what is the need, right? So from Zscaler, you get multiple services, and it is software as a service because you're not going to get any hardware, you're not going to get any hard copy of the software. Like from cloud, you will be getting all these services. Now, whatever services we have, like Zscaler, internet access, Zscaler, private access, Zscaler, digital experience, okay, and Zscaler deception, right? Zscaler trust portal, multiple other new services are also there from Zscaler. Now, what are the common services which are now adopted by the industry? Right? These three services, which you will see commonly adopted by industry, right? Now, why it is getting popularity? What difference it brings from the legacy security systems that we need to understand. What happened earlier, traditional architectures, in your branch, we used to have a firewall. So overall architecture looks like you have this router having your MPLS circuit, connecting it to your data center, right? I'm just keeping it simple, hub and spoke. This is your hub, this is spoke, right? And you are keeping your resources, your application are hosted in your on-premise setup, right? And users who are sitting inside the branch, the private application flows like this. In a secured way, it is happening, right? Earlier, we used we were not getting local internet breakouts on the branches. Few critical services were there on internet, and only few branches used to have the internet circuit. And we have to isolate it from our MPLS network. So your firewall is connected to internet. Let's take an example. This is critical branch where big shots of the company are sitting and they need internet access. So we have the internet circuit available from them. And then you have a different VLAN for internet. So I'll not go into much details like, you have the primary circuit, backup circuit, and then redundancy and all that stuff. We keep it very simple. So traffic is coming, private traffic is coming, hitting the MPLS router, taking the MPLS cloud and going to the server farm. Internet bound traffic from the machines is coming like this and breaking out like this, right? So you are getting the security posture from this device. When we were having this setup, there were no cloud, no SaaS based softwares, right? And very less internet bound traffic. It was working fine because SAP is the crucial software. You get copy of it, you install it in your servers, and you provide services. Exchange, Microsoft Exchange, or O360 Microsoft services. You get the software, you install it inside your server farm, and you start using it. Mail services and other. Now, what happened? What initiated this digital transformation? First of all, and earlier, your work from home users were also very less in enterprise network, right? And if it used to be, then there was a big stack deployed in the data center to provide the work from home. And if any branch is not having internet circuit locally available, then we used to send the traffic towards the data center for backhauling. And this is how we used to break out the internet traffic. Now, what triggered the digital transformation? During COVID, first of all, the migration of your on-prem applications to cloud, one driving factor. This could be your private applications as well as your public applications. Then SaaS services are coming out, rather on-prem solutions. SAP is saying that take services from my cloud. Microsoft is saying take services from my cloud. I'll not give you the software anymore because softwares were getting leaked. They were not able to make the good revenue out of it, right? Uh, Unauthorized use was there of the softwares. Licenses were getting cracked and all that stuff. So they came up with software as a service where they will charge you the subscription cost and you need to take the license. This is the easiest way of selling your services with the license, okay, and get protected because you don't give your code to anyone. And there are chances now that your services cannot be replicated. Your code is secure because you control it. Okay. Now what happens when services are moving on cloud, software as a service? Your applications are also moving to cloud because EKS cluster, Docker, these architectural shift from monolithic to microservices is another driving factor. Now, third point is like work from home users or work from anywhere users. I can work from anywhere. I should not restrict myself only to office premise. This led to the growing need of internet circuits instead MPLS circuits. Because what was happening when this transition happened, when your applications they move to their respective cloud, SAP, and this is O365. What happened? You know, the load on this hub location increased for internet traffic, rather private traffic, right? So just a minute, I'm just getting one. So this load increased and applications were hitting the data center, and from data center, they were going to the internet. This is the legacy architecture, backhauling. Okay. Now, due to which, what happened on data center, your internet underlays bandwidth size was getting increased. I mean, we need to keep on adding more and more bandwidth, right, to acquire to accommodate this the requirement from the branches, right? And your work from home users, they were also connecting to the data centers, and from there they were breaking out to the internet, to the branches, wherever they want to go, right? So it was bringing a lot of load on your data center devices, and it was leading to bottlenecks, poor network performance, device failure. So many things were happening. So then, as an alternative, these solutions came into the market, right? The Zscaler, because any which ways you have to switch your circuit, your underlay circuits from MPLS to public mediums like internet, public circuits, internet, LT, whatever it is. Right? Now, when you're transforming your underlay, this is your branch, you have this router, you're removing the MPLS circuits and you're installing internet circuits. Right? And you have to access your resources inside branch. What you can do is you can build IPsec tunnel, right? Site to site tunnel. Few organizations, they have done this as well. Makes sense, right? But how will you secure your transaction to a SaaS platform? When your traffic is breaking out from the user machine towards the SaaS platform, let's take an example. I want to access Office 365. I want to access SAP, which is there on their respective cloud. So your traffic is coming, hitting the switch, the router, and then you're getting the local breakout, right? And you're accessing it. So you need to place firewall here to secure this transaction. Okay? So you need to put firewall here to secure your transaction. And similarly, your other internet bound traffic, whatever it is, URL filtering, whatever you want to do, you can do it with the help of the firewall. Now, the problem with this setup is like, if you have 500 users, you have done the sizing as per the 500 users. In future, if you're going to have the 5,000 users, you have to upgrade your hardware. The entire stack you have to upgrade. Right? And then similarly, if you have workloads available in cloud, and if you're building your tunnels, right, then this is additional headache of managing your cloud resources and all that stuff and how your traffic pattern will look like. What Zscaler says that you don't need this complex architecture because maintaining IPsec tunnels, it's a headache, operational headache, and people lose focus from their security posture. What Zscaler says that let me simplify this journey for you. Okay? With my cloud, I will provide you the security services so that you just need to focus on your security posture, right? So this is the branch from where now Zscaler is offering you complete solution that you don't need any tunnel anymore. You just forward your traffic towards me and I will take care of it, right? Now, when a user is sitting here, so I'm talking about very, very early days of Zscaler when SD-WAN was not there. And you will see it in production environments as well. So we used to deploy ZCC connector in every machine. And this connector was building tunnel 1.0, right? It was your proxy method, HTTP connect method is being used to build the tunnel, right? And it used to connect with the Zscaler cloud. So your tunnels were getting built from the endpoints. And for server and other traffic, we can have the GRE, right? Built from here to the cloud for servers and other CCTV and other equipments, right? So we also used to call it GCC over GRE setup. This was the legacy architecture of Zscaler, which it is also there in few organizations so far. But now they are doing the migration from, they are revamping their architecture as per the SD-WAN. So what was happening? Whatever traffic, web traffic were generating from these from your machine, it was taking this tunnel, and then obviously you have GRE, right? Because this is VCC over GRE, and it lands up to the Zscaler, and from there it goes to the internet and SaaS platform, right? Then they launched private access. So first they came up with Zscaler Internet Access, which was able to solve the problem of internet and SaaS applications. Then they came up with ZPA. Now, this private access is ensuring the way you are accessing your private applications from branch as well as from uh, user machines, from work from home users or road warriors. We call it in Zscaler terms. How do you handle your private application traffic? Because in the past security breach, we have seen that RA VPN solutions like AnyConnect, Google Protect, Checkpoint, SSL client, Fortinet SSL client, they were giving you complete network access, right? Whether you are authorized or you're not authorized to access any resource, you get the access of complete network. As per the ZTNA, Zero Trust Network Access, the principle says that we need to give access to the users, the access of the applications to the user, which they are entitled to work upon. We should not be giving them complete access of the network. And this is what ZTNA is, right? So now what Zscaler private access says that I'm not going to give the entire network access to the users. I will only give application access to the user. It means IT users should be able to access the IT related applications. HR team should be able to access the HR related applications. Uh, Developers, they should be getting the developer applications, and other users, marketing, they should be having access to the social media and all that stuff, right? So whatever marketing tools you have in place as well, they should be getting access to those applications only. We are not going to open up the entire network for the users because we don't trust anyone. And the major driving factor of this was like insider attack. This insider attack was increasing. Employees, they were doing, they've started doing attacks, or they were started leaking out information, or their machines were getting compromised and attacks were getting initiated from inside the network only, right? So the very examples, I mean, there are multiple examples which I have seen in the industry past couple of years, how attacks were happening, the remote users, right? How to give access to internal resources, right? We use RA VPN services, remote access VPN services, and we give network access to access the applications. Now, what happens is like, to enhance the performance, we use a split tunnel that only your private traffic will come to me. Your internet traffic will break out locally from your system towards the internet. And this is the interview question as well. I'm not sure whether somebody has asked you or not. Can you run multiple RA VPN services all together? Right? The answer is yes, we can run it if they are deployed in split tunnel. So in my system, I can connect all the RA VPN connectors. Let's take an example. I will be using Cisco AnyConnect to access my resources in AWS. And that subnet is, let's take an example, 172.16.0.0/16 or something like that. I will be using Palo Alto Global Protect to access my resources which are deployed in on-prem data center, and my subnet will be 10.1.0.0/16. I will be using Checkpoint to access something which is deployed in private cloud environment, and it could be 192.168, something like that. Why we are bifurcating the subnets? Because these remote access VPN clients, they are going to control the endpoint routing tables. Okay. So if you have this, if you do route trade, the moment you will connect to your services, right? These remote access VPN services, you will see this table gets altered. Right now, default route is pointing towards the gateway and traffic is breaking out to gateway. The moment you connect to these connectors, you will see that your tunnel is getting formed by using this underlay, and then everything is going towards the data center or wherever it is, right? If it is full tunnel, if you have split tunnel, then your internet traffic will break out via underlay circuit, and your rest of the traffic will use the respective tunnels to break out to their respective destination. This is how you can deploy it. And then comes a ZCC. Because this is your private traffic, which makes sense. But if you want to secure your internet traffic, then you can also deploy Zscaler client connector, and interoperability is there, right? But normally, when people understood this thing, when to deploy inter ZCC, so normally in production environments, what we have seen people using, I mean, the IT heads, they have deployed the architecture like this, that I will be using Cisco or Global Protect, any one connector or two connectors to access the resources, and internet traffic was going unprotected. What hackers were doing, they were compromising because you're accessing any website, any malicious website. You have received one email, you clicked on it, malware got inside your laptop, right? And then you have got the complete access of your private resources. So lateral movement of the malware was very much possible in these architectures. This is where Zscaler come into the picture. Initially, they started with internet access, so they were able to secure these transactions. But later on, they figure it out that the way private applications are getting access these days, it is also vulnerable, and we should be protecting it. And then comes your ZPA, Zscaler Private Access. Now, what Zscaler Private Access is doing? Zscaler Private Access is giving you secure way of connecting to your private infrastructure. Let's take an example. This is the road warrior, right? So this service is connected to Zia public cloud. This service is connected to ZPA public cloud, right? And Zia is giving you secure transactions to internet and SaaS based applications. And ZPA is giving you secure transaction to your on-prem resources, on-premise applications. Let's take an example. This user is from finance department. So he will have access to your SAP or whatever on-prem application you use for your internal finance audit or something like that. That finance application will be available to this user. Okay. So now question comes like, this is like you're completely dependent on Zscaler for your traffic forwarding. Something goes wrong with Zscaler, complete outage. So you will see rare deployments like this. You will now see that for branches, we will have SD-WAN because industry is moving towards SASE architecture and secure access service edge. Earlier, it was not having SD-WAN as part of it, but these days it is having SD-WAN as part of it. And later on, it could have some other component as well. So SD-WAN plus SAC, right? These things like secure service edge, your SAC platforms. And your forwarding method depends. It could be SD-WAN, it could be the client connector, it could be the pack file. It depends, right? Now, when industry has started moving towards the SASE, right? So what happens is like how your overall architecture is looking like on your branch. You have the SD-WAN router, right? You can put them in active passive or active active. You have the underlays deployed. These are the underlays which are terminating your ISP line 1, ISP line 2, right? Now, if you're doing such arrangement, then you need to ensure that both routers are in active active. Otherwise, you can have cross connection for active passive, right? And then comes your LAN segment where you can connect your downstream devices. Okay. Now, what I can do for branch traffic forwarding with Zscaler, what we normally say as part of the best practices, we say that when user is coming inside the branch, I will disable the ZCC connector because what I will be doing, I will be having dedicated tunnels from my SD-WAN routers towards the Zscaler. So my overall architecture is going to look like this. I will be having this SD-WAN fabric. SD-WAN fabric is nothing but your IPsec tunnels to provide you connectivity with your data center, which we have already seen at how it works, right? And here you will be having your data center location where your private applications and whatever it is available, right? In your DC. With the help of the SD-WAN routers, we build this fabric and we securely move our traffic, private application traffic via SD-WAN fabric, right? Now, for SaaS applications and internet traffic, we need to break out the traffic locally from the branches, right? Because then only you will realize the performance of the network. Because these days, the main problem organizations are facing with Teams, Microsoft Teams. It is very bandwidth chatty application, and it is creating so much problem for the customers, right? They want to get a solution that they can optimize it because see, a IT team could be like they can enjoy their days if everything is moving smoothly. Because if any issue comes up, then they cannot take a deep breath, right? So till what extent you will upgrade your bandwidth? That is another thing because you need to keep cost in your mind, right? You need to do the cost management and all that stuff. Now, when you're sending this local breakout, right? What strategies I need to follow? Either I can give direct breakout and I can break out unsecurely. I can take firewall subscription on this SD-WAN router. I can secure this transaction, right? Then it has its own caveats, not a scalable security solution. See, with security, the only problem is like the granular security you're trying to do. If you're trying to apply SSL decryption, if you're trying to do deep inspection, your throughput will go down, right? And that's the reason people don't want on-premise solutions for deep inspection. Cloud-based solution is like these are hyperscale solutions. If you turn on the SSL decryption on Zscaler, it is not going to impact
Hello,
the
am I
throughput
audible?
of overall transaction. Yeah, Vishant, you're audible. Hello. Anything you would like to ask?
Hello.
Is Anna audible? No. No.
Yes, you are audible.
You are. Maybe is having some mic problem. Okay, so now it's like why Zscaler? Very first thing we get to hear why Zscaler, why we should not buy licenses on our SD-WAN router to secure the transaction, and why do we need Zscaler, a cloud-based security solution, to provide us the uh, you know security, right? Many driving factors are there. Cost is there. Many features are there, right? And it has its own benefits and caveats, right? Pros and cons is always available with the technology. Now, if I see this Zscaler cloud, so what I need to do is in Zscaler cloud, I need to build my tunnels. This is the best practice to have dedicated tunnels from your on-premise setup towards the Zscaler cloud, right? So that your internet traffic should go to the Zscaler and from there it should break out. So, on branches, you don't need a firewall anymore. You save the cost from that perspective. On the other hand, when you do SSL decryption on Zscaler, it is not going to impact the throughput of your transaction, which we see normally in case of firewall. This is the common problem. And without SSL decryption, you cannot provide deep inspection. That's why endpoint security is needed. Because these are the intermediate devices, your network switches, firewall, router. Your traffic is getting generated from this machine itself. So we need to have a look what this machine is doing. Any software is getting installed in it, any malware is getting inside it, which is affecting the overall security posture. That's why endpoint security is needed, right? Because most of the traffic you cannot decrypt during the transaction as per many compliance and regulatories we have. Okay. Now comes, okay, this is the way internet access is working. When this user will go away at home, right? The moment this
Sorry,
GCC
Nitin.
will, Mhm.
Oh, I just lost a bit over here. So, I heard you that you were saying the Teams traffic is very, very high. So, what we should be doing that? So that traffic will be
Vishant,
going through.
I'll take doubts after completing the session. Huh?
Okay.
I mean, let me just explain. So when this user is going to the home or anywhere, right, and he would like to access the corporate resources, so with the help of the Zscaler private access, he will access the private resources. So ZPA public service edge will be there where you know you will be getting the connectivity to your private data center, to your cloud with the help of the app connectors. We will study about it in detail. And internet traffic will be secured via Zscaler public service edge, right? And it will be giving you secure transactions to internet and SaaS based applications. Okay. Now, this is how it is going to look like from architectural point of view. And in this training, what we are going to do is since we have already implemented SD-WAN, right? So if I will show you the agenda of this entire training, why it is different from previous trainings of Zscaler. What we have done, we have couple of locations where we have installed SD-WAN. Let's take an example. This is branch one. We have the SD-WAN router here, right? And we have the SD-WAN fabric built towards the data center, right? And what we have done here is like we have the secure SD-WAN. Secure SD-WAN is like SD-WAN with security licenses. So every transaction is getting inspected. Now, this fabric is up and running, transactions are happening. As next part of this training, what we are doing, we will deploy Zscaler, internet access as well as private access. And we will integrate this solution with this existing solution. And we will work out the different use cases that how my internet traffic will flow, how my SaaS application traffic will flow. Right now we are connected through Teams, right? How to optimize it, right? Whether we need to pass Teams traffic through Zscaler or we should bypass it, right? What is Teams direct routing which we need to think about? Okay, so we will cover all these things, right? So very first thing which we are going to start with is like Zscaler internet access, right? We will be deploying the ZCC connectors in the user machines. We will be deploying it inside our servers, right? And we will be deploying the app connectors as well in our on-prem setup, cloud setup in AWS and GCP, and we will be onboarding everything to this cloud for traffic inspection. If I will show you the fabric, let me just log in real quick. So here, if you will see, the SLAs, they are up, right? If you will see SD-WAN rules, so you will see that how transactions are happening. SD-WAN zones, you will be able to see, right? WAN 1, WAN 2. This is underlay, then overlay will be built, right? And then we will integrate Zscaler zone as well. And if you will see the transaction details and all that stuff, the dashboard, so you will be able to see everything, right? How things are happening, current sessions and all that stuff, and how things have been protected, right? So this is what will be covered here, right? We will build tunnel with the Zscaler as well as we will also build tunnel with the Prisma access, right? I will show you that how you can integrate your existing SD-WAN solution with these SSE providers. Okay. And then we will bifurcate our traffic. Right now, what is happening? Zscaler is not there in the picture, right? So whatever traffic users are generating, either it is breaking out locally and getting inspected through this device, and private application traffic is flowing via this particular SD-WAN fabric. So we need to uh, secure this transaction with the help of the Zscaler. This is what we are going to do. Now we will first start with Zscaler internet access, and we will start reading about that architecture, that how Zscaler internet access service has been designed. What are the underlying principles, architecture, right? So we need to learn that, right? So basically, Zscaler has been divided into three planes, right? Your control plane, data plane, and statistics plane. So that we will learn, we will understand, we will see how traffic is reaching to Zscaler nodes, how the security policies are getting implemented on those nodes, I mean on those user packets, right? What traffic forwarding methods we get from Zscaler to forward traffic towards the Zscaler data centers, right? How the overall architecture has been designed and it has been implemented, right? And what best practices we can follow to implement this solution in the production environment without, losing your security posture, and how you can optimize the cost and you can get the best network out of it. Once you understand this architecture, then it will be like piece of cake for you to integrate any other solution like SD-WAN with Prisma Access, SD-WAN with Netscope. So, you can configure it in a way. So we will be doing the real-time deployment, and because this is not going to be virtual lab training, because the Zscaler is a cloud-based service. Your Prisma, your Netscope, other things. These are cloud-based services. You cannot do it in virtual lab, right? It is software as a service. You have to buy the licenses to do this, right? And similarly, we have the Fortinet licensed boxes in our locations. Fabric is there, and we will be building the tunnels, and we will be getting the real-time, in-depth insight of the packet forwarding and real-time operational challenges of the technology, right? So I hope from architecture point of view, it is clear that what we are going to do, right? From tomorrow onwards, we'll pick up the dedicated Zscaler based training. So we'll start with ZIA, then ZPA, and we will integrate it with our existing SD-WAN Fabric. So what we are doing is, what I'm going to make you learn is like migration. So SASE implementation is not a one-day job. I have already discussed this approach many times before. One way is like do it greenfield, that SD-WAN and SASE, you're building it all together, and right from day one, you will be sending your traffic. Another way is like first roll out the SD-WAN and then understand the operational challenges, problems, optimize the policies, and then integrate your Zscaler as a phase two part of it. Do not roll out the entire solution altogether because you won't be able to understand where you are getting the problems, right? And then it becomes very problematic approach. So I will be making you learn the migration and real-time project deployment of Zscaler. So what we are going to cover is we are going to cover the design part of it, how to design the solution, how to build the architecture, how to implement it with best practices, and how to troubleshoot the problems. This will give you the complete insight of design, implementation, and troubleshooting. Okay, now I'm open for discussion. I'm stopping the recording. Yeah, please tell.